We've been talking about quadratic functions and how to identify the different pieces of them. So today I'm going to go over numbers 3, 4, 5, and 6 in our quadratic booklet. So you can check your work and you can take the notes. After that, when we come back to class the following day, we will work on 7 through 10. So hopefully this will give you a little bit more clarification and you can ask any questions that you might have. So on number 3 here, we talked about finding our specific points. Now this one only has 3 visible points on our parabola. So in our table, -2, 1, 2, 3, 4, 5, 6. -1, 1, 2, 3, 4. And 0, 1, 2, 3, 4, 5, 6. Keep in mind that these are buddy points. Okay, a buddy point is going to be they have the same y value, but they have different x's. This one does not have a buddy point, so this is a vertex. And if we look at our picture, it is at the bottom of the parabola. So this is actually a minimum vertex. Through this minimum vertex, we can draw a vertical line. Remember, this is our line of symmetry or axis of symmetry. And it is crossing the x-axis at -1, which remember, this is our HK. So this matches that. We can look here based on roots, x-intercepts, zeros, and solutions. So remember on roots, we can have 1 root, we can have 2 roots, we can have no roots. And this one does not cross this x-axis. So this one actually has no roots, or you could write none. That just means that when we do our equation down here, okay, that it's going to, it might look a little different. We'll see. We haven't encountered no roots, so we'll see if it looks any different or not. Our axis of symmetry we just did. X equals -1, and our vertex is -1, +4. Remember, this is our HK, and this is always x equals h. We do have our buddy points at -2, +6, and 0, 6. 0, 6 is also our x-intercept. Remember, this is our C on our equation. Our vertex was a minimum because it is opening up. And this is going to be a min value. Remember, this is always your K. So our minimum Y value is going to be 4. How many solutions? Well, we said right here, there are no roots, so there are no solutions. Why? The parabola doesn't cross the x-axis. Okay, and that's okay. So right here, the regression in standard form, this is where your calculator is going to come in handy. Remember, you need to have a minimum of 3 points, which we have. So we're going to say menu. Remember, we need to do number 4, list and spreadsheets. We always put X and Y up here at the top. We never ever put anything in this equals row. Okay, there's kind of a glare there. Let me turn this light off. Now, when we look at this, we can put in -2, -1, and 0. Oh, I hit the wrong button. 0. Here we can put in 6, 4, and 6. Now remember, when we go to cell C1, it needs to be blue. If you have a cursor blinking in this, it's not going to work. So it needs to be blue. Menu 4, 1, and this is not exponential. We've done that. This is quadratic. So we're going to say number 6, X, Y, enter, enter. So here is our equation, 2x squared plus 4x plus 6. So y equals 2x squared plus 4x plus 6. And look, C is our 6 and you can see it is here, our y-intercept. Now, the vertex form, remember, y equals a times x minus h quantity squared plus k. That is on our formula chart. You can see in our standard form, a is 2, b was 4, c was 6. So this 2 is going to go here. So we can say y equals 2, parentheses, and we have h and k already, so we just have to plug them in. X minus, h is a -1, so if we have minus a -1, 2 sticks make a plus, that was from 6th grade, squared, k is a +4. So let's talk about what that means. Well, if it was -2 or -1 +4, remember insiders lie. Positive is usually right, but it's inside. So this went left 1 and up 4. This 2, okay, so this was our -1, this was our 4. Let's talk about the 2. And in order to do that, we're going to go back to our calculator. So remember when we do this, it saves it in F1. So we're going to say Control Doc, and we're going to add our graph. So if we go up, there is our equation. And then we're going to hit Tab, and we're going to put in our parent function, x squared. You could also go through, and you could draw it here if you wanted. We know that it goes up 1 and over 1, up 1 and over 1. I do want you to notice that this one is going up 2 and over 1. So when we draw this, if I was going up 1 and over 1, you can see that it would actually be wider, right? The parent function is wider. So, and we're going to do a little bit more investigation on this a value, but because this a is 2, we can say that it is also going to be vertical stretch. And don't worry too much about that part. We're going to continue to look at that and we'll do an investigation. But I just want you to know that if a is different, it does change the width of the parabola. We also did a word problem. Okay, we said this was our max vertex. We said pay attention to your scale. We said the ball started on the ground at 0, 0. We said this was our line of symmetry. And since it was 1, 2, 3, 4, 5 from the place that the ball started, that means the ball will be 1, 2, 3, 4, 5 where it ends. Where did the ball hit the ground? Well, we're going to have to count this. Each one is a half. So a half 1, half 2, half 3, half 4, half 5. So the ball hit the ground at 5, 0. This is, remember, this is a root, a solution. Both of these are x-intercept or a 0, right? We need to make sure we know that vocabulary. If you wanted to draw, it's not perfect, but it's close, right? What goes up must come down. Trace the path of the ball. Blank depends on blank. Remember, y always depends on x because y is the dependent variable. Our dependent is height. So we can say height depends on dependent variable was height. Independent variable is seconds. So height depends on seconds, right? Or you can say height depends on time. Now we need to use our calculator. Find the quadratic equation. Okay, so I'm going to come over here. I'm just going to make me a little mini table so I can see my coordinates and I know what to put in. We know we have 0, 0. We know we have 0, 5. We need to find this max vertex here. So a half, 1, a half, 2, a half. So 2 and a half. Now this one is counting by threes. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And that's what we're going to put into our calculator for that regression. Now, keep in mind, we're going to start a new document every time because we don't want our data from the previous spreadsheet to mess us up. So again, for x and y, 0, 2.5, 0. My y values are 0, 30, and 5. Go to cell C1. Menu 416, X, Y, enter, enter. Oh, I did something wrong. What did I do wrong? I'm not sure. Maybe I just hit a button wrong. 416X. All right, let me pause this for a minute and see what happened. I see what I did wrong. I wrote my point backwards here. I wrote the x-intercept instead of the y, so sorry about that. So we're going to change this to a 5 and this to a 0. Some of you may have already caught that. Now let's try it. There we go, x and y. Yay, it worked that time. All right, so my a is negative 4.8. So I can come down here. Y equals negative 4.8x squared. My b is 24, positive, so plus 24x. My c is 0. I could put plus 0 here, but I don't really need to. Remember, this is also our y-intercept. Okay. Then it asks us to apply what we've learned. Where is the ball after 4.5 seconds? Well, we have this equation and we know that seconds is our x. So we can plug in negative 4.8 times 4.5 squared plus 24 times 4.5. And let's see what it says. So I'm going to do Control, Doc, and I'm going to add a calculator this time so I can plug in what we just wrote. Negative 4.8 times 4.5 squared. Remember, it's a smart calculator. It'll do it all for you. Plus 24 times 4.5. 10.8, and that our y is in feet. So we can say 10.8 feet. Now, that being said, keep in mind, if I'm at 4.5, so this was 2, 3.5, 4, 4.5, and this was by 3s, 3, 6, 9. So maybe it's here. Obviously, my parabola isn't drawn quite correctly. Then I know if this is a half a second from where it fell on the ground, if I come a half a second here, I should have a buddy point. Okay, because what goes up must come down. So at a half a second from landing, it's at 10.8. So that means at a half a second from being kicked, it's at 10.8. Using your calculator, when will the ball be above 20 feet? So if we go to our graph, which will obviously look better than ours. So again, Control, Doc. Now we're going to look at the graph. Up arrow has it already typed for you, unless you just want to type it again. Now remember, we can't see the whole thing here. So if you remember way back, we talked about menu for A. It's going to automatically resize it for us. Now, we don't need any of this stuff on the bottom because this is going to be negative time. Over here is negative feet. We don't have any of that. So we're only looking here. But the beauty of this is we can say Control T. Okay, so here are all of our points. 0, 19, 2. Okay, so the question was above 20. So at 1 second, it's at 19, 2. So just after, like at 1 point, maybe 1 second, it might be at 20. It's going up, it's going up. Went up, it came back. Here is our vertex. Here it came back down. So it is above 20 between 1 and 4 seconds. Now, this is a graph that is continuous. So we can say 1. Now, it's not exactly at 1. Because at 1, it was at 19.2. 1, and this is time we're talking about. So x less than 4. So between 1 and 4 seconds. Why did the ball appear twice at this height? Because what goes up must come down. Okay. All right, then we have a domain and a range. Domain are our x's, right? You can either look in your table, you can look in your graph. So we went from 0 to 5. and we included those. 0 is less than or equal to x is less than or equal to 5. And these have or equal to's, unlike these, because we are including those numbers. The range, 0, we said this was 30. And we are including those. It is in our table here. 0 is less than or equal to y is less than or equal to 30. We will continue to work with that. That was a struggle. Where will it be at 6.5 seconds? Well, at 5 seconds, it was on the ground. So at 6.5, it is still going to be on the ground. Unless it fell into a hole, then it might be negative, but we're going to assume not. On the ground. So that is 3 and 4. So I do want to go over 5 and 6 with you real quick. I'm going to go a little bit faster, but if you have a question, you can always pause it and send me a note. Now, I do want you to notice number 5. This is different than what we've had. This only has one root, okay? And we're going to see if that changes anything for us. So we do have, what is this? 1, 2, 3, 4, 0. We have a coordinate here and here. Here and here. So we're at 2, 1, 2, 3, 4, 3, -1, 4, 0. Then we can, and you can see the pattern: 5, -1, 6, -4. So we do have our buddy points here. This is going to be a max vertex. I'm sorry, it's not on the screen because it is at the top. But this is also our root, because it is the only one that touches that x-axis. So this is a case of one root. So we've had 2 roots, we've had no roots. This is one root. Our axis of symmetry. So this one, the root is also the vertex. This is our HK. Remember, the axis of symmetry is x equals h. So x equals 4. It's where it crosses the x-axis. We have several buddy points. You can list any of these. I'm going to go ahead and write 3, -1 and 5, -1. If you wanted to use 2, -4 and 6, -4, you could. It does happen to be a max vertex. Remember, the max value, this is your k, and my k is 0. This is my biggest y value. And we don't write y equals or anything like that. We just write the number. Our y-intercept was, sorry, that was an x-intercept. We don't know the y-intercept yet, but we're going to talk about that. Remember, this is always your c from your equation. So maybe when we get down here, we can do that. Concavity is, how does it open? It opens down. So concave down. All right, the range. Remember, this is your y's. So our highest y is in fact 0. We can see it here as well. And it's all of the y's below that. So we can write infinity, or we can just say y less than or equal to 0. Gotta use your calculator here. If you didn't write all 5 points, that's okay. You only need 3. So again, we're gonna start a new document because we don't want our data from the previous one to go mess up this one. So we're going to go 4 x y. Hopefully these keystrokes are becoming pretty familiar to you. -4, -1, 0, -1, -4. Oh, wrong way. So we have cell C1 menu 416, x and y. Here's my equation. So like down here, y equals -x². You could put the 1 if you wanted, plus 8x minus 16. Now remember, this is our c. This is going to be our y-intercept. So now I can come here, 0, -16, which makes sense. If I look at my graph, it's going to keep going down. Vertex form. Okay, that's your HK. So remember, it is y equals a times x minus h quantity squared plus k. So we're just going to plug in what we know. Now a is negative here, so that's okay. -1, x minus h is 4. quantity squared, k is 0. So we can write 0, but we don't need to. What does this mean happened? Well, this means that it went right 4. My parent function is here. It went 1, 2, 3, 4 to the right. And we know that because insiders lie. This went right 4. But also we know on the parent function is always concave up, and this one is concave down. So what happened was it reflected over this x-axis. That's what that negative does. Reflection over x-axis. The last one is the factored form. This is your cross puzzle. And I'm in fact going to factor out this -1. So when I do that, I have -1, and then I just have a positive x squared minus 8x plus 16. So a times c is 16, b is -8. So -4 and -4. This happens to be that perfect square trinomial package. So we can write y equals -1 because that was our GCF. And then we have x minus 4, which if you look, x minus 4 times x minus 4 is the same as x minus 4 squared. And you can always graph all 3 of these in the calculator to double check. I would like you to try number 6. So if you'll pause the video and then unpause me when you're done to check to see how you did, because our next ones are going to be a grade. On this last one, you can see it's a little different. I've given you a table of values. You're going to have to create your graph. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 7, 0, -7, 0. This does happen to be a root. -6, +3. -5, +4. And then you can see it goes down 4, +3. So this is going to be our max vertex. Okay. We didn't have the other root, but if we continue this pattern, right, these are buddy points, then this next one would be our other solution, 0, x-intercept, root. Okay, so here is our picture. Now, I'm drawing this so you can see it. Really, this is discrete information, okay, because it is only dots. So that is actually going to be important. What are our zeros, our x-intercepts, our solutions? -7, 0, -3, 0. Hopefully you got that. Our vertex, label it on the graph. It says this is our max vertex. Right, we labeled them in the table. If you labeled them on the graph too, that's fine. Remember, you need to learn all 4 of those words, and make sure you label it as a max vertex. When you come down here, we said it was -5, +4. Axis of symmetry, remember x equals h, so x equals -5. Put it on the graph. Line of symmetry, x equals -5. You can see we went through -5 on the x-axis. Buddy points, there are several buddy points listed. I'm going to go ahead and just list this one. -6, 3, -4, 3. The y-intercept we cannot see yet, but remember this is c from our equation, so maybe once we get our equation, we'll get that. This is, remember, max value is going to be your k, so it is 4. This is discrete. So when we write our range, we're only writing the y values from this table. And remember, we have some repeats, but we don't list the repeats. 0, or -5, 0, 3, and 4. That is our range. And I got that from up here. Okay. Quadratic regression, again, we're going to use our calculators. I'm going to come back up. Again, start a new document every time so that you do not get other information confused. So 4, x and y. -8, -7, -6, -5, -4. You could put the -3 in there if you wanted. Doesn't really matter. It's not going to change anything. Menu 416, X, Y, enter, enter. Here is our information. So I can come down here and I can write Y equals -1x² minus 10x minus 21. So remember C, so I can come here now, my C, 0, -21, which makes sense because if I look at my graph, it's going to go way down here to cross the x-axis. Vertex form, all right, so HK, here's our HK. Y equals A is -1, X minus H. Now H is negative, so minus a negative is a positive. Insiders lie. K is +4. What does this mean compared to the parent function? Well, we know, we talked about this earlier, so this negative is a reflection over the x-axis because remember on the parent function, we're here. It is opening up, it's concave up. So this one is reflecting over the x-axis. And then what is it doing? Well, insiders lie. So this is really left 5. K says up 4. When we go through and we do our factored form, I'm gonna do my little cross puzzle over here. And I'm gonna take out that -1 first. So -1 and I get x² plus 10x plus 21. So my AC is 21 and my B is 10. So I know 7 and 3. So I can write Y equals, I took out a -1. My A is 1, so it's just x plus 7, x plus 3. And again, we can graph all 3 of these to double check them, okay? I do not want you to start on 7 through 10 right now. We're going to talk about that in class. But if you have any questions, send me a note in Google Classroom so I can help you.